Good morning. Total of three classes were taken from the chapter of Special Theory of Relativity, which was discovered by Einstein in 1905. Few topics were discussed. Today I am going to discuss time dilation. You might have heard this term, time dilation. Means slowing down of time. Time itself is not absolute. If you study special theory of relativity, you will find that time itself is not absolute, as well as length is also not absolute. So later I will discuss on length contraction. Okay. Today in this class I am going to discuss on time dilation. So time is not absolute. What is the meaning? Time is relative. For myself, for the occurring of an event, say it takes 2 hours of time. For myself, I am talking about myself. I am standing here inside this room, and this house is fixed on the surface of earth. And with respect to myself, with respect to me, an event. I have already discussed what is an event. An event, say I am considering one event that I am throwing a particle, or say, not particle, talk about a train. Say from Kachrapara station, my location is Kachrapara, that's why I am talking about Kachrapara, okay? From Kachrapara station up to Krishnanagar, okay? It is almost 55 kilometers, and for a train, it takes almost 1 hour and 10 minutes of time to reach from Kachrapara to Krishnanagar. So I am talking about as an observer. I have noticed this thing. Say the train is not taking any stoppage in between these two stations. It moves with a constant velocity. The train moves with a constant velocity, and it starts departure from Kachrapara station and it reaches to Krishnanagar station. And it takes 1 hour and 10 minutes of time. So for myself, I am as an observer, I am observing that thing. But for another observer, say that observer is moving in a car with some speed. For that observer, the same time, my time was how much? It was 1 hour and 10 minutes of time. For that observer, the time will be different than that of myself. Okay? So that will be the result when you apply the theory of relativity, special theory of relativity for such events. So what was the event? Here event was the departure of the train from Kachrapara station, and it reaches to Krishnanagar station after some time. So here two observers are there. One observer is myself, who is standing just beside the railway track and observing the event. Okay? And another observer is inside a car. The car is moving with some speed. That means the car and the train has a relative speed with respect to each other. So time noticed by me and noticed by that observer will be different. That is the result of special theory of relativity. So how this happens? That thing I am going to discuss in this class. How this happens. How this is possible. So before 1905, many theories were discovered. So electromagnetic effect, electromagnetism, etc. These were discovered, And Einstein thoroughly gone through all these theories and he found that velocity of light is constant in vacuum. I am talking about only vacuum, okay? In other medium such as glass, velocity of light is different. You know this thing. Through water, velocity of light is different. Okay? So I am talking about velocity of light in vacuum, which is 3 into 10 to the power 8 meter per second. Different experiments were conducted by different scientists across the globe, and all of them found that velocity of light is constant. It does not change with respect to with respect to the observer or with respect to the source. Source means source of light. We know that. You have this experience that suppose a train is running with a speed of 100 km per hour and I am standing on the top of the train, on the roof of the train. I am standing. Okay? In the direction of the motion of the train, what was the speed of the train? It was 100 km per hour. So in the direction of the motion of the train, if I throw a stone in the direction of the motion of the train with a speed of say 20 km per hour. So what is the speed of that stone with respect to an observer who is standing on the ground? We know that this speed will be 100 km per hour plus 20 km per hour, that makes 120 km per hour. Okay, so you are observing that there is addition of velocities when they are in the same direction, and if they are in the opposite direction, if I throw the same stone in the opposite direction of the motion of the train with the same speed 20 km per hour, then what will be the speed of the stone in that case? For an observer who is standing on the surface of earth and observing this event, he will notice that speed of the stone is 100 km per hour minus 20 km per hour, that is 80 km per hour. If he is able to somehow measure the speed of the stone, he will get this velocity, 80 km per hour. Okay, so when in the same direction it is 120 km per hour, when it is in the opposite direction it is 80 km per hour. So you can see here addition and subtraction are happening. Addition of velocities and subtraction of velocities are happening. Okay, you can notice these events easily. Now think about a light source in the front of train. Lights are there. So light has a speed of 3 lakh kilometer per second or 3 into 10 to the power 8 meter per second. So if an observer is observing or trying to measure the speed of the light standing on the surface of the earth when the train is moving with a speed of 100 km per hour, it has been experimentally found by all the scientists that addition of velocities means addition of the velocity of light and velocity of train does not occur. Always they have found that speed of light remains constant at 3 lakh km per second. For the opposite direction also same thing. If you fix a light at the back of the train, okay, and again if you measure, there also you will notice there is no subtraction of velocity. Again you will find the same speed of light as 3 lakh km per second. So different experiments were done by different scientists All of these things you will find in literature. So what is the conclusion about speed of light? Conclusion is that speed of light remains fixed. It remains constant in vacuum. I was talking about observer who was standing on the surface of the earth. If you do the experiment like that, the observer is also moving, then also you will find that velocity of light does not change. So conclusion is that, so these are experiments. These are not theories, these are experiments, okay? So according to these experiments, the conclusion is that velocity of light does not depend upon the relative velocity of the observer or the relative velocity of the source. Speed of light remains always constant. And this is the ultimate speed in the universe. Ultimate maximum speed. Okay? So what? So far, I have discussed about the constancy of velocity of light. Now, think about an experiment which is called thought experiment. We are not going to conduct that experiment practically. Okay? This is a thought experiment. Suppose this is room. Inside this room I am taking this class. Suppose this room is a compartment of a train. This room is a compartment of a train. In this compartment, there is floor, there is ceiling. Suppose between the ceiling and the floor, the vertical distance is h, small h. Okay. And the train is moving with uniform speed. One thing keep in your mind that in case of special theory of relativity, only inertial frames are considered. Inertial frames means frames which are moving with a constant velocity with respect to one another. So all the inertial frames are equivalent. And two postulates are used for the discussion of or the analysis of special theory of relativity. Those two postulates or axioms, and axioms are same. What is postulate? Postulate means something which is taken to be true by everyone. Everyone means every scientist. Something which is taken to be true by everyone. That is called postulate or axiom. Both are same thing. So, so this height is h. This is what? This is a compartment of a train, and this train is moving with a uniform velocity of v. Okay. Now, if suppose there is light source at the floor, on the floor there is one light source. So that light source is focused in the upward direction. Okay. So light, it has some speed. The speed is 3 lakh kilometers per second. So light rays emitted from that source will reach to the ceiling, and it will take some time because there is some distance in between the ceiling and the floor. It will take some time. I am the observer. I am sitting inside this train compartment. I am sitting in this train compartment. Okay. So I have my own clock. I have my own clock. By using that clock, I can measure the time taken by the light ray or the photon particles. Light rays are composed of photon particles. You know this thing. So, time taken by the light ray to reach from the floor to the ceiling, where the height, distance between these two, ceiling and the floor is h. It takes some time. Suppose I have noticed the time is t, only t, small t, and height is how much? H. What is the velocity of light? It is denoted by c, small c, right? So, what is the relation among these three variables? H, c and t. We know that velocity multiplied by the time taken is equal to distance. Therefore, h is equal to what? H is equal to ct. We have got this relation. This is known to you. From class 5 you are habituated in using this equation. H is equal to ct. Distance is equal to velocity multiplied by time. Okay? So that thing I have used here. And I am the observer sitting inside this train compartment. Okay? So I have found H is equal to ct. This is equation number 1. Now think about an observer who is not moving with the train, who is standing on the surface of the earth, and he is noticing the movement of the train, the motion of the train, he is noticing. And he is also having one clock with him. And he will notice the same event. What was the event? Event was light emitted from the source, which is fixed at the floor of the train compartment and reaches to the ceiling. Same event is being observed by that outside observer, outside of the train. So outside observer, he is standing on the surface of the earth. He is noting same thing. So the light rays take some time to reach from the ceiling to the reach from the floor to the ceiling. So it takes some time. Time is required. So in this small interval time, no doubt this time interval is very small, but in this small interval of time, train was in constant motion with a velocity v. So this train will move in the forward direction by some distance. Is there any doubt about this? No, you should not have any doubt about this. Within this small interval of time, the train compartment will move in the forward direction, means in the direction of the motion, to some distance. Who is observing the velocity v? The outside observer. Velocity of the train, I have mentioned that velocity of the train is v. Who is observing this velocity? The outside observer, who is standing on the surface of the earth. With respect to earth, he is still, he is static. So with respect to him, velocity was v. Suppose for him, when the light ray emitted from the source and reaches to the ceiling, within this time, the train has moved to some distance. So with respect to him, suppose time is denoted by t prime, t dash, okay, t prime. With respect to his clock, he is measuring the same thing. He is noticing the same thing. He is observing the same thing. Okay? From floor to ceiling. This traveling of light is being observed by the observer. Okay? So what? So the linear distance will be how much according to the outside observer? That will be that constant velocity of the train v multiplied by the time elapsed according to his clock, t prime. So v multiplied by t prime is the distance. Here, this is the horizontal distance. Okay? But according to that observer, light ray does not move in the vertically upward direction. For myself, I am the observer sitting inside this frame. For myself, it is vertically upward. Because with respect to me, there is no relative motion between the light ray and myself. There is no relative motion. So I will see that the light ray goes vertically in the upward direction. But for that observer, in that interval of time, the compartment has moved to some distance in the horizontal direction, horizontally, some distance. So what happens? Here, the tip of this finger, light source, here this is the ceiling. Now after that short interval of time, this compartment has moved to somewhere here, okay, somewhere here. So light rays for that outside observer does not move in the vertically upward direction, it moves this way, obliquely. Okay, this is the ceiling. Within that short interval of time, compartment has moved to some distance. So this was the beginning and this is the end. This is the end. Light ray reaches here. For whom? For the outside observer. Okay, light rays reaching here. So what is this distance? What is this distance? This distance is time multiplied by velocity. Time noticed by whom? The outside observer. So time is t prime and velocity. How much? We are talking about the velocity of light. And already I have mentioned that velocity of light is constant. That means velocity for this observer, for myself, who is sitting inside this train compartment, is c. And for that outside observer also, that velocity is c. Velocity of light does not change depending upon the relative motion of the observer. That was mentioned in the very beginning of this class. Okay. So for these two observers, velocity of light is same. So velocity of light will be c. So this oblique distance will be how much? It will be c multiplied by t prime. Horizontal distance was how much? It was v multiplied by t prime. And the vertical distance was how much? It was h. It was h, the distance between the floor of the compartment and the ceiling. Right? I have drawn that sketch. I am just showing it. You can see here. Is it visible? This is position A. From here, this is position A. A is written here, B is written here. This is what? This is train compartment. Okay? You can see. Is that visible or not? Oh. So this horizontal distance is Vt prime. Okay? This oblique distance, the compartment has moved to this position. Okay? So this oblique distance is Ct prime and this vertical distance is h. Okay, this is outside observer and this is inside observer. So first we have got this h is equal to Ct. Can you see? H is equal to Ct. Okay, and then so this makes a right angle triangle. That horizontal distance, the height of the compartment, and that oblique distance, the path or the trajectory of the light ray, which was Ct prime. So we can easily write for right angle triangle, square of the hypotenuse is equal to square of the base plus square of the height. So that simple formula I have used here. So you can see here, I have written Ct prime whole square is equal to h square plus Vt prime whole square. Okay, so from there you will get you will get t prime into root over of c square minus v square. T prime into root over of c square minus v square, you can see. So now comparing equation number 1 and 2. From equation 1, we got h is equal to ct, and from equation 2 we have got h is equal to t prime into root over of c square minus d square. Now compare these two equations, so you will get t prime is equal to t divided by 1 minus, you can see here, okay, t prime is equal to t by root over of 1 minus v square by c square. So that thing you will get t prime is equal to t prime is equal to t divided by 1 minus divided by root over of 1 minus v square by c square. So denominator means root over of 1 minus v square by c square, that is not 1. If that is 1, then t dash is equal to t. But v is not 0. V is having some value, non-zero value. V is having some non-zero value. So v square by c square, v is less than c. Nothing can cross the speed limit. Speed limit is velocity of light. So v is always less than c. That means v by c is always less than 1. So v square by c square is always less than 1. So 1 minus v square by c square is always less than 1. So square root of 1 minus v square by c square is always less than 1. Right? So t prime is equal to t divided by a denominator where denominator is less than 1. So which one is more? T prime or t? T prime is equal to t divided by a denominator or divided by a number, that number is less than 1. So obviously t prime is more than t. T prime is more than t. Say just for example, the denominator is 0.1, means root over of 1 minus v square by c square. That quantity is 0.1. So t prime is equal to t by 0.1 means what? 10t. T prime is equal to 10t. So t prime by t is equal to 10. T prime by t is equal to 10. That means t prime is more than t. Denominator is always less than 1. So t prime is always more than t. So time observed by that outside observer is more as compared to myself.